Greetings. I welcome you all to this particular lesson. So this is an interesting topic that we are starting. It is called practical electrical circuit. So I want you to follow me clearly and attentively so that you are going to see everything that I'm going to do here. So this part here, we are talking about something that we get to call electrical power. We are talking about what? Electrical power. Previously, if we are given a question to say, what is power? When I tell you to say, define power, you are going to tell me that power is defined as the rate of what? Doing work, or the rate at which work is done. That's what you are going to tell me. But this electric power that we are talking about is defined as the what? Is defined as the rate of what? Using electrical energy. So the rate of using electrical what? Electrical energy. This is what we are defining this particular power. So we are not talking about that power that if I just tell you a question to say, what is power? You are going to tell me, we know that power, if a question comes, what is power? You are going to tell me power is the what? The rate of what? This is the rate of doing work. This is what you are going to tell me. But here I've introduced another word, which is electrical power. So electrical power is the rate of using electrical energy. Energy, this is the ability to do work. So, and this work is being done electrically, electrical energy. This is what I'm talking about. So you now need to understand that examples of electrical power that we get to talk of. So let me say examples of what? Maybe I want you to understand this clearly. Examples of what? Electrical power. So examples of electrical power. We can talk of what? We can talk of a cooker. So power, first of all, is measured in what? Watts. The SI unit for power is watts. This is what you have to know. So examples of this electrical power, we can talk of a what? A cooker. So we talk of what? A cooker, which is what? 8,000. 8,000 what? Watts. This is a cooker. So it has got a power of what? 8,000 watts. We can now talk of a heater. So when we go to a heater, you discover that a heater has got a power of what? 3,000 watts. Then we've got, let's say, a TV. You discover that most of the TVs, it's what? 120 watts. And the bulbs, some bulbs get to have 60s, others 100. So these are just some of the examples that you need to get, that you need to understand. So let me say a bulb, you can have maybe a question in an exam. So a bulb is what? 60 and what? 100 watts. So these watts, you can also put here watts. I guess this light that is here is not disturbing anyone. Just a torchlight from the phone. So this is what you need to know. These are certain things that you have to understand. So we are talking about a cooker, heater, TV, and a bulb. So when you are given a question in an exam, if they tell you to say that you are given a question to say a bulb of 60 watts, so that 60 watts that you are given, what you need to do now, you need to change now. So you convert to what? 60 joules of electric energy into light and heat energy per second. So if you are given, I want you to understand that a bulb of, so I've said that a bulb, I will say a bulb of what? 60 watts. So a bulb of 60 watts converts what? It is going to convert. So it converts 60 what? 60 joules of what? Electric energy. It converts 60 joules of electric what? Electric energy. So electrical energy there, it gets to convert 60 joules of electric energy into what? Into light. So that we get to have some writing. So into light and what? I'll say light and heat. So light and what? And heat energy per what? Per second. I'll say heat energy per what? Per second. This is what you have to do. Per what? Per second. So this is what gets to happen. If it is 80,000 watts, meaning it is this heater, it is going to convert 80,000 watts into what? Into 8,000 joules of electric energy that is going to make those plates to light up into heat energy now, where we are able to see some energy get to come out. This is what is happening. So a bulb of 60 watts, it is going to convert 60 joules of electric energy into light and heat energy per watt per second. That is what you are supposed to know. After understanding this concept that I've just shared here, you now need to understand that the formula for that power that is there is what? We say power is equal to voltage times what? Current. This is a formula that you need to know. This is a what? A general formula. So power is equal to voltage times what? Current. So if I give you a question, you need to understand that, okay, if a question is talking about voltage, a current, then they're telling you to find power. This is a formula you need to know. What if you are told to find voltage? Voltage is equal to what? So you divide here. You say, okay, voltage is equal to what? Voltage, if you make the subject of the formula here, it is equal to power over what? Current. This is a particular formula that we get to use, isn't it? We are going to use this particular formula. This is a formula we use. What if you are told to find that current? Current is equal to voltage over what? Power over voltage. Voltage is equal to power over current. Current is equal to power over what? Voltage. These are formulas that are coming from there. These are formulas you need to understand. I guess you are able to remember, you are going to remember these formulas. But once you just know this one, because it is this same one that is giving these two formulas. We are just making I the subject of the formula, V the subject of the formula. This is what I'm just doing. And from the formulas that are given you, I want you to understand that there is this particular formula where we say power is equal to what? Energy over what? Over time. This is a particular formula. Power is equal to what? Energy over what? Over time. So in this case, this energy that we are talking about is called electric energy. This is the electric energy. So this is to tell you that. So what are we saying? If we make this one electric energy as the subject of the formula, we are going to say energy is equal to power times time. Isn't it? This is what we are going to do. Energy is equal to power times what? Times time. These formulas that I'm giving you, you need to know them. You need to make sure that you do what? You understand them clearly. So these are formulas that you need to understand. If I give you a question here, you discover that these are the same ones that you'll be using. So we need to make sure that this time that is there, time should be in what? Hours. Then this one, if we are calculating electric power, electric energy, you need to make sure that this power is in kilojoules. I'm going to explain by that even as we get to move forward. I'll explain so that you understand. I guess you are able to see these particular formulas. Let me give an example here so that you get to know where we are going and how questions do come. because most of you can even start saying, all these formulas, these are simple formulas. So far I've just given you two. Then from these two formulas, we are just making subject of the what? Subject of the formula. That is what we are doing. So let's say you are given a question to say, you've got a question to say a 12 what? A 12 volts battery. So let me say you've got this question. A 12 volts battery is giving off. So they are telling you to say that it is giving off what? It is giving off a current of, it is giving off a current of 2 amps. A current of what? A current of 2 amps to a resistor. To a what? To a resistor like this. Then the question is saying, find the power now. Find the what? Find the power. They are telling you to say, find the power now. How can you answer this question? You know that the formula power is equal to voltage times current. This is the formula. So power is equal to, what is the voltage? 12 times, what is the current? 2. So the answer there is what? What answer we get in there? When we multiply, we are getting 24 watts. So this is the what? This is the formula. Once you understand the formula, it's very easy to get the what? The answer. So everything gets to ID in the what? In the formula. That's what you are supposed to know. This is question number 1. What if you are given question number 2 that is like this? They're telling you to say that a potential difference of 12 volts. A potential difference of 12 volts is applied. So they're telling you to say that it is what? It is applied across. So they're telling you to say that it is applied across the what? Across the 4 ohm resistor. Across the 4 ohm resistor. So I'll say across the what? Across the 4 ohm resistor. Then full stop. Then they tell you to say find the power. Find the what? Find the power. So how can you find the power now? What you need to do now, you know that power is equal to voltage times current. The voltage, quite right, we have. That is the voltage there. Then how about the current? Current is not given. What are we going to use? The formula for current, there is already this particular formula that I gave you. Voltage is equal to current times resistance. So we know and understand, okay, we've got the what? The resistance, we've got the voltage, we're able to calculate current. So current is equal to voltage over resistance, isn't it? When you make I the subject of the formula. So what is the voltage? Voltage is 12. Resistance, that is 4. Then if you divide there, what answer are you getting? We are getting 3 when you say 3 amps. So this is the what? This is the current. So I've calculated current. I just substitute here. Voltage, that is 12. Current, that is 3. When you multiply there, what answer are you going to get? You are going to get 36. So we just say 36 what? 36 watts. This is the answer. You are done. So this is what you are supposed to do. I don't know if you are able to see this. So this is how questions will also be coming in your exams. You just need to make sure that you understand these particular formulas that I've given you. So this one we already did in our previous lesson, isn't it? This is the one that we were using. So you get to use everything that you know on a specific topic to answer some questions that you are going to be given. This is something that is so easy. This is something that you need to enjoy. Then after looking at these questions, how to calculate power and the like, there is also another part now that is now called the cost of electrical energy. This is now where I want you to hear me well, because most questions get to fall under that part. These are the conclusion of this particular topic that we started. So we say the cost of what? The cost of electrical energy. We look at the cost of what? Cost of electrical energy. the cost of electrical energy, how to calculate my units now that you get to use in your homes. So you discover that when you use the electricity that is being supplied by the ZESCO, you will need to have a meter. We call it, what do we call it? We call it that one that is called electric meter, isn't it? So there in the meter, you are going to find the units going to be written in what? So I'll say electricity. So I'll say electricity in meters. In those meters is written. So is written as what? Is written as kilowatt hour. This is how it is going to be written. Written as kilowatt hour. So kilowatt hour, this thing that is here, this is what we get to call a unit. This is a what? This is a unit. So by using this unit, the cost of electric energy can be calculated as 1 kilowatt hour. 1 kilowatt hour is equivalent to what? Is equivalent to 1 unit. So 1 kilowatt hour, it is just the same as 1 unit. So 2 kilowatt hour, it means that those are 2 units. Okay, the units, there are many. The units they've given us 500 units. So that is 500 kilowatt hour. It is coming from the word kilowatt hour. This is kilowatt. This is power that is in what? Kilo. So they had to divide by 1,000. Then this one, this is time. This is what? This is time. This one, this is power. So to find that electric energy, this is the reason why we get to use this particular formula, where we get to say that for us to calculate the energy consumed, so I'll say the energy that is what? Energy that is consumed. For us to calculate the energy consumed in what? In kilowatt hour, we get to use this formula. We say electric energy is equal to power times time. This is a formula we're going to use, and I gave you this formula when I was just starting this. I guess you remember it. So this is a particular formula that we get to use. Have you seen? This is the formula where this is the electric energy. This P, you know that P is what? P is the power of what? Electric components. Which, so I'll say this is the power of what? Power of electric components. The power of electric what? Components. So that power of electric components is in what? Kilowatt hour. I mean, you will just say kilowatt. It's just the power, kilowatt. Then the T that you are able to see, that is the what? That is the time. So I'll say that is the what? That is the time taken. And this time taken should be in what? Hours. You need to make sure that this time taken is in what? Is in hours. That is what you need to get and understand. This is something that is so simple. I want you to get this, and I want you to understand this in an easy way. So for example, if I give you, I'll just give you one question, then I give you a simple exercise. I see if people have understood what I've just said. Let's say you are given a simple question that is saying that if, let me say that if electric energy, so I'll say that if electric what? If electric energy costs, so if it costs 50 kwacha per unit, so if it costs what? If it gets to cost 50 kwacha per unit, 50 kwacha per unit, what is the total cost? So I'll say what is just the cost of using what? The cost of I'll say the cost of using 1,000 kilowatt hour. What will be the cost of using this? So looking at this question, the way this question has come, it has come in a way that the question is telling us that If electric energy costs 50 kwacha per unit, isn't it? So I'll say per unit. What is the cost of using these ones? So what you need to understand, you know that, okay, 1 kilowatt, I would say 1 unit. If 1 unit is costing what? Is costing 50 kwacha. And remember what I told you. I told you to say kilowatt hour is just the same as a unit. This is what I said. Have you seen? So 1 kilowatt is the same as 1 unit. So coming here, 1000 kilowatt is just the same as what? 1000 units. It is the same as 1000 units. What is the answer? X. These are going to cancel out. 1 times x, it is x, which is equal to. So if you multiply there, what answer are you going to get? You are going to get what? 50,000. So the answer is just 50,000. It will cost what? It will cost 50,000. When you multiply 1,000 times 50, you get 50,000. So that is the 50,000 that is going to be there. That is the answer that you are going to get. I guess you've seen how I've answered this particular question, just like this. So this is something that is so simple, something that you need to make sure that you understand. Let's say you are given another question. Let us look at now a question that can come in a different way. So let me put another example. This one will be the last one. Just a last example. Then we see how we can answer these questions. Just like this. So we get to answer these questions just like this. You are done. We are not even struggling. We are answering these questions in an easy way. So let's say you are given a question to say a bulb. So the question is saying that a bulb. So I'm going to say that a bulb, I will say a light bulb. So let me say a bulb. So I'll say a bulb of what? A bulb of 1000. I'll just say 1000 watts. So a bulb of 1000 watts is, let me just say 100 to say 100. So I'll just say a bulb of 100 watts is what? Is used. So this one is what? Is used for. So is used for 7 hours. I'm going to say it is used for what? It is used for 7 hours. Then I put a comma there. Then I ask you to say what is. So I say what is the what? What is the energy? So I say what is the what? What is the energy cost? So I say what is the energy what? What is the energy cost? If so, if the what? If the cost of if the cost, I will say if the cost. So if the, let me say if the what? If the energy. So if the energy, so if the what? If the energy, this is what I'm going to say. If the energy cost, so if the what is the energy cost? If the energy, what is the energy cost? If the energy costs 50 kwacha per unit. 50 kwacha per what? Per unit. You are given this question. How can you answer this particular question? What are they telling you? They are telling you to say that a bulb of 100 watts is used for 7 hours. What is the energy cost? If the energy costs 50 kwacha per watt per unit, so we don't have any unit here that we've calculated. So a question that comes like this, where you've got the power and the time, you need to get that power. The power is what? The power that we are given is 100 watts. We get the 100 watts and divide by what? 1000. So that we form kilowatt. So when you divide by 1000, what answer are you going to get? So when you say, get your calculator, 1000, you say 100 divide 1000. What is the answer? 0.1. So you say 0.1 kilowatt watts. We've put the word kilo because we've divided by 1000. Then we've got the time, which is already in hours. Time is already in what? Hours. So what is the time there? The time is 7 hours. So we already have the time, 7 hours. What is the energy? I say energy is equal to power times what? Time. This is the electric energy. This is the formula. I'm using this particular formula so that I know the number of units that have been consumed. What am I going to do? I'm going to say this is now equal to energy is equal to what? What is the power? 0.1. This one that is here, 0.1 times. What is the time? The time is what? 7. So I multiply by 7. So I just get my calculator and multiply 0.1 times 7. What is the answer? 0.7. 0.7. This is 0.7 kilowatt hour. Once you calculate this, you are done. What you are just going to say. So we conclude by saying we know that 1 unit is equivalent to what? 50 kwacha. There we are given 50 kwacha per unit. Then this one is the same as units. So 0.7 units. I told you kilowatt hour is units. X. This cancelled. 1 times x, it is x, which is now equal to. Then we multiply. We find the answer 0.7 times 50. What is the answer? 35. So we say it is what? 35 kwacha. That is the answer. So meaning the energy there that will be needed is what? 35 kwacha. For us to use this bulb of 100 watts for 7 hours. So this is where we end from. Let me now test you with a question. I see how you are going to answer it. Thank you so much.